Good afternoon, everybody. Welcome to, I hate to say this, but our last meeting together this summer for Chem 1105 with your host, I'm getting all choked up, with your host, Dr. White. Hi, everybody. It's our last time together. Let me remind you, tomorrow at 8 a.m. or maybe even a little earlier, I will send out the password for the final exam. You will have until Friday, 2 p.m. to upload your answers for the final exam. If you don't get it in by 2 p.m. Friday, the 4th, I reserve the right to give you a 0 or subtract a lot of points from your final exam score. Probably give you a 0. I need things on time. It's the end of the semester. I've got to get my grades in, so you better get your answers up on time. And as I have here, again, tomorrow will be the final exam. And here I say up to 50 points. I'm going to make that 100 points. In other words, give you a 0. So please be on time Friday by Friday. Again, tomorrow, since it's the final exam, I will not be holding a Zoom meeting. So this is our last one, unless you come to my office hour tonight. Now, something I did this morning, as you know, yesterday was the deadline, or last night was the deadline for all labs submitted. All your labs have been graded and your extra credit project. They are now in Blackboard. Please check to make sure I didn't miss anything. I don't think I did, but I don't walk on water unless it's frozen. Then I even stay off it. In other words, nobody's perfect. If I have not graded a lab that you submitted, please email me by Friday noon at the latest with the lab or labs that I did not grade, and I'll grade them. Now, let me give you a heads up. Hopefully by Sunday, 7 p.m. or earlier, I hope a lot earlier, I will have in Blackboard your final exam, all your point totals, and your course grade. I will also submit it to the COD system called what the heck is it called? Hold on one sec. I always got it mixed up between the two schools I teach at. COD My Access. Actually, they don't put it in there anymore. It goes through an app in Blackboard now. But anyways, when I put it into the official system, it can take up to 24 hours or more before you see the official grade. However, what's in Blackboard that I will put, that will be your grade. Now, if you like what I did this semester, please go to ratemyprofessor.com and say something nice about me. If you didn't like it, you can do that too, but I thought hopefully I did a good job. Remember, this is an internet course, and I don't have to do these videos or have this live Zoom meeting, but I did so you will do well in my class, and hopefully you all do. Now, if you really, really like what I did this semester, please send an email to the following people. Go to Blackboard. You'll see important email addresses. I have both as a PDF and a MS Word file. And please send a letter, email. If you want to send a US mail letter, you can, but send an email to Dr. Brian Caputo, who is the president of COD. And if you do that, also copy the Board of Trustees. And if you're going to do this, write it, let it sit overnight, and then send it after you've read it again. And please address them as Dr. Caputo. And I'd appreciate it if you really, really like what I did this semester, if you do that. All right, let's finish up. Oops, I don't have, where did I have it? Ah, here it is. All right, home stretch, everybody. Let's go through the review for test number 4, things you should know. What's an acid? A Bronsted acid is a proton donor. What's a Bronsted base, or just a base? It's a proton acceptor. You should know HCl, H2SO4, HNO3 are acids. You should know sodium hydroxide, KOH, and ammonia are bases. This comes from Chem 1105, test number 4, review. And it's in the lecture section of Blackboard for 1105. Now, because water dissociates in the following reaction, chemists found this ionization constant, Kw, named after me. Now, I wish it was, but every time I say it, I think I do. It's named after me. And that's the hydronium ion concentration, H3O, plus times the hydroxide ion concentration equals 1.0 times 10 to the minus 14. Now, an acidic solution is when the hydronium ion concentration is greater than the hydroxide. Having trouble with my pen today. That's better. And that's acidic. A basic solution is when the hydroxide is greater than the hydronium ion concentration, H3O plus. And a neutral solution is when they're equal. And because it's hard to look at numbers like this and say which is greater and smaller one is scientific notation quickly, the pH scale was developed. And the pH scale is minus the log of the hydronium ion concentration right here. Now, my special gift to you this semester, don't tell anybody I'm being nice, but if the hydronium ion concentration is 1.0 times 10 to the minus x, then the pH is x. And if you look at important practice problems for the final exam, I asked in 16, if the pH, what is the pH of a solution if the hydronium ion concentration is 1.0 times 10 to the minus 3? We're trying to find a pH. We're given the hydronium ion, pH equal minus the log of the hydronium ion concentration. That's given to you and important information, final exam. I'd highly recommend all of you look at that file that's in the lecture section of Blackboard and see what you don't have to memorize. And that's equal minus log of 1.0 times 10 to the minus 3. This is 1.0 times 10 to the minus x. pH is x. X is 3. pH is 3. Now, you should know this scale. It's not given to you in the important information because it's probably one of the most important things I'll teach you this semester. See, it even says it on the slide, important. And that's the pH scale. pH goes from 0 to 14. In the middle, 7, that's the neutral pH. Below 7, it's acidic. The closer to 0, the more acidic a solution is. And above 7, that's basic. The closer to 14, the more basic a solution is. Now, remember, a buffer solution is a solution that resists major change in pH. In other words, the pH doesn't change when a small amount of acid or base is added to that. And I taught you about titrations. When you have an unknown acid or base reacting with a known acid or base, a certain amount at certain molarity, this allows you to determine the molarity if the acid is unknown or the base is unknown. And this is called a titration. At neutralization, when the pH indicator changes color, moles of acid equals moles of base. And for monoprotic acid and base, which is all we'll do in this class, you can break that down to milliliters of acid times molarity of acid equal milliliters of base times molarity of base. And if we look at problem 12, let me make sure you can see problem 12. And the answer is you can't. So I can do this. If you look at problem 12, this is from chapter 7, practice problems. You have to add 1.35 times 10 to the third milliliters or 1.53 m molarity, you know that, sodium hydroxide solution. The key here is to neutralize 1.87 times 10 to the second power milliliters of aqueous HCl solution. What is the molarity of the HCl? And here we're trying to find the molarity, capital M, HCl, and you're given the milliliters and the molarity, the base you need to neutralize that acid, and you're given the milliliters of acid that are neutralized. At neutralization, this is a titration. Moles of base equal moles of acid. And that breaks down to milliliters of base times molarity of base equal milliliters of acid times molarity. By the way, it doesn't matter which side you put the two expressions. And put the numbers in. We want to solve for molarity of HCl. How do we get rid of 1.87 times 10 squared milliliters? Anything divided by itself is number one. It's gone. So I divide by that. Whatever I do to one side, I have to do the other. I did. This cancels out. I rewrite it, calculate it. Now, you could also, if you look on your calculator, I have as 11.0. You could have seen 1.10 times 10 to the first power. Now, remember, all calculations use proper significant figures. And for this one, it's a multiplication division. Remember, you get the same number of significant figures in your answer as the number that has the fewest significant figures. And this has 3, 3, 3. So my answer has 3. Now, one thing I didn't mention earlier that I should is number 9. And if you have a solution of OH minus equal 1.0 times 10 to the minus 11, what is the pH of the solution? And is it acidic, basic, or neutral? So we're trying to find a pH. We're given the hydroxide. However, pH is minus the log of the hydronium ion concentration. So we have to do 2 steps. In step 1, we convert the hydroxide to hydronium. How do we do that? From important information, final exam, hydronium times hydroxide equal 1.0 times 10 to the minus 14. If we're solving for H3O plus concentration, we got to get rid of OH minus, so divide by it. Anything divided by itself is the number 1. Whatever I do to one side, I'll do to the other. This cancels out. You have this equal this. Put the number in, calculate it, and you get 1.0 times 10 to the minus 3. Are we done? No, we're trying to get pH right here. So second step, we convert the hydronium ion concentration H3O plus to pH. And here we have pH equal minus the log of H3O plus. And put that number in. When this minus the log of 1.0 times 10 to the minus x, the answer is x. In this case, x is 3. And if you remember the scale I showed you, anything below 7 is acidic. Next, I talked about organic chemistry. We didn't have enough time to talk about that. I could do a whole 2 semesters on it, and I have. It's called another class. But anyways, you should know the most important part of organic chemistry, the most important element, is the carbon element, carbon atom or element. And you should know there's always four bonds to carbon. You should know a hydrocarbon is a molecule with only carbon and hydrogen atoms. There are 2 types of hydrocarbons: saturated hydrocarbon, again, hydrocarbon, molecule with only carbon, hydrogen atoms, which all carbon-carbon bonds are single bonds. Unsaturated hydrocarbon are molecules with only carbon, hydrogen atoms, and 1 or more carbon-carbon multiple bonds, meaning double or triple bond. Remember, there are 3 types of covalent bonds: single bond, double bond, triple bond. You should know how to find functional groups. We just went through that for test 4. You look for anything that's not a carbon or hydrogen atom, or that's not a carbon-carbon single bond. That's going to be a functional group, and that's where all the fun happens. Now I'm being biased because I'm a synthetic organic chemist. And you should know how to draw condensed structures, how to put in the hydrogens, because you know there are 4 bonds to carbon. Whoop, wrong thing. Oh no, I don't have something open I need. And I'm going to have you have some fun. I'm not going to hog all the fun today. All right, for that molecule, why don't you put in all the hydrogens? Your turn to have fun. Am I nice or what? Don't answer that. All right, looks like everybody's done. Well, that was quick. My turn. And if we look at this first carbon, it has 1 bond. There should always be 4 bonds to carbon. 4 minus 1 equals 3. And same thing with this carbon, this carbon, this carbon, wow, and this carbon. So let's look at this carbon right here. There's 1, 2, 3 bonds to it. There should always be 4 bonds to carbon. So 4 minus 3, 1. There's 1 hydrogen. And if we look at this carbon, there's a bond there and a bond there. And there should always be 4 bonds to carbon. So that means that has 2 hydrogens. And same thing with this one. And that's how you do it. Now, I didn't ask you to draw these, but cycloalkanes, every bend in a line is a carbon. And on test 4, if you remember, how many carbon atoms are in this molecule? Your turn to have some fun again. Well, I've been sharing a lot of fun with you this semester. Hope you enjoyed it. And if we look at this, how many carbons? Well, if we look at the ring, every bend in a line is a carbon. 1, 2, 3, 4, 5. So the ring has 5 carbons. Then I have a carbon here, 6, and a carbon here, 7. So the answer is how many carbons in that molecule? 7. Now, I asked you to learn 2 general reactions and know how to use them. And the first one is combustion. You take any saturated hydrocarbon, react it with oxygen. The actual chemicals you get are carbon dioxide and water. You also get an important thing called heat, which is how we heat our house, our water, and cook our food in the United States and anywhere else in the world. Even if you're not using natural gas, using wood, you're doing combustion. And give the product or products for the following reaction. Your turn. And before I answer, I'm going to get some water. And if we look at this molecule, even though it's big and scary, no, it shouldn't be. This carbon and hydrogen, carbon-carbon single bonds. It's a saturated hydrocarbon. And we know from the general reaction, saturated hydrocarbons with oxygen give carbon dioxide plus water. And the answer here, therefore, is carbon dioxide and water. And if I ask, give the product or products, you do not have to balance the equation. Organic chemists are lazy that way. We don't have to, we don't. Now, another reaction I showed you was hydrogenation. And let me rewrite it on the whiteboard. You take any double bond, react it with hydrogen gas, H2, and a catalyst, and the catalyst can be platinum, palladium, or nickel. You break one of the bonds, and each carbon of the double bond gets a hydrogen. Now, other than combustion and another reaction, which I don't teach that often, you don't break carbon-carbon single bonds. It's very rare. You don't. Therefore, your turn to have some fun. Give the product or products for the following reaction. All right, so what do we do when you look at a molecule, organic molecule, you look for what's different. Ooh, a double bond. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond should get your attention like that. Hopefully you heard my hand clap. And we have a double bond. And we're reacting with hydrogen, and nickel is a catalyst. And remember, the catalyst can be platinum, palladium, or in our case, nickel. And you break one of these bonds, and each carbon gets a hydrogen. So do you break carbon-carbon single bonds? No. So I have 1, 2, 3, 4, 5, 6 across. So I'm going to end up with 1, 2, 3, 4, 5, 6 across. On these two carbons, I have a CH3 group, which is called the methyl group. They're still going to be there. Now, these two carbons are these two carbons. And I broke one of the bonds because that's what our general reaction says. And each one of those carbons gets a hydrogen. It looks like two eyes looking at you. Dr. White's being foolish. I can be that way. And now you know there are 4 bonds to carbon, so you can fill in the rest of the hydrogens. Remember, you don't break carbon-carbon single bonds. Double and triple bonds, you can. In fact, your body breaks down the double bonds in beta carotene to make a molecule called retinal that's good for your eyes, which is why they say carrots are good for your vision. How much? I don't know. I'm not an optometrist or an eye surgeon. I'm an organic chemist. I'm going to skip this stuff. All right. You should know, just like on test 4, how does soap work? I'm going to write it down on my whiteboard. Leaving my class, you should know, how does soap work? And when I was washing my hands earlier together, I was thinking of this, but I'm an organic chemist. You should know the structure of soap is a nonpolar tail and a polar head. You should know water, H2O. That's an ugly looking too. Hold on, let's fix this up. Is polar. You should know dirt is nonpolar. And the important piece of the puzzle, how soap works, I'm writing it in large font because it's so important. Like dissolves like. And you learned earlier when we went through solutions, that means polar things are soluble in polar things, nonpolar things are soluble in nonpolar things. And if you have a piece of dirt, when you wash your hands with soap and water, the nonpolar tail of the soap molecules are attracted to the dirt. The polar head wants to be as far away, so it's on the outside. And this totally, with a lot more molecules, I'm not going to draw them in, surrounds the dirt the form, and you should know, a micelle. And now the micelle looks polar to water, and water says to the micelle, I'm polar, you're polar, let's go down the drain together. And they do. And this is something I expect you to know leaving my class. And by the way, you can share this with your friends, neighbors, and loved ones. I bet they don't know when next time they clean their hands, wash their hair, wash their clothes, wash their dishes, wash their car, they're making the micelles with the dirt or grease. Grease is also nonpolar. And that's what gets it off of the item, whatever you're cleaning, and goes down the drain. Which reminds me, next week I should wash and wax my car. And we covered this. Here's a nice picture of micelles. Even says, know this. You should know. How does a towel work? By hydrogen bonding to water. And here's cotton, and see the hydroxyl groups? That's like in water, O minus H plus, and it hydrogen bonds to water. Well, I think I'm just about finished, but I have a special surprise for you. But I'm going to cut most of it out of the video, but I may leave one picture. Now, all semester, I've talked about all the years I worked in the chemical industry. Was Dr. White lying to you? Good question. Let's find out. So now you know it is true. I did work in the chemical industry. But anyways, and I've also been teaching for a long time. With that, I'm done. I'm done for today. I'm done for the semester. Now, let me remind you, tomorrow morning, I will send out the password for the final exam. And you have until Friday, this Friday, the 4th. Hold on, let's find out if I'm right. For those who don't know, www.timeanddate.com, their calendar. I've been using this for I don't know how many years, but this Friday, the 4th, you have until 2 p.m. to upload your answers as a single PDF file to the assignment area Blackboard. Anybody who doesn't, I reserve the right to give you 0 points for your final exam. So please be on time. Also, don't forget, by 7 p.m. or earlier Sunday, I will have all your total points, totals, and your course grade in Blackboard. I'll also put it in the school system, but it may take 24 hours or more. If I do it on Saturday, you may not see it till Tuesday or Monday or Tuesday, but the one in Blackboard will be correct. And finally, or second to finally, if you like what I did, go to ratemyprofessor.com and let everybody know. If you really, really like what I did, send an email to Dr. Caputo, the president of COD, and copy the board of trustees. He does read his email from students. I know. How do I know? Well, you got to figure that out yourself. And with that, I hope you enjoyed this semester. You now know my world of chemistry is your world of chemistry. Next time you look at a bottle of water, remember that's molecules of water. This is chemistry. The next time you feel the wind on your face, that's molecules of oxygen and nitrogen hitting you hard. And the next time you wash your hands, you understand what's going. And with that, I'll say goodbye for the last time, unless you want to come back and watch it. And to one of my students, I'll say Dankeschön, ich spreche Deutsch. Let me check something. Someone was just, hold on, was just talking about German wines. If you really like German wines, go to Benny and get the Piers Porter Golden Drachen, either the Spätlese, Auslese wine. And I've worked in Germany a lot when I worked in the chemical industry, and that was my favorite wine. I worked in the Golden Drachen area, the Piers Porter area where that wine came from. But with that, I'm going to say gang gesund for the last time. Maybe not if you come to my office hour tonight. And thank you for being in my class this semester. Gang gesund, which is Yiddish, go and help. If you've seen in the newspaper, COVID is making a spike again. I'm still wearing my mask. Last Friday, I got I think my third or fourth booster, I lost count now, of the COVID vaccine. And I'm in a high risk group, if you haven't noticed, not youngster, but even young people. I've had students in this class and the other who came down with COVID this semester. So it's still out there. But with that, I'll say, gang gesund. Goodbye now. Bye.